Okay, so now we're going to look at specific types of sequences in series. We're going to look at what's called arithmetic sequences in series. So what's an arithmetic sequence? Well, one definition, a sequence where the difference between consecutive terms is constant, or you can think of it as a sequence where the terms increase or decrease by a constant amount. If they decrease, we actually look at them increasing by a negative. And whatever they're increasing by, whatever that common difference is, we call that D. So let's look at an example to get an idea of this then. So are the following sequences arithmetic or not? And if they are, find D. So if you think you understand what arithmetic is, go ahead and pause the video right now and try these. Otherwise, let's do them together. So let's look at A. To go from -3 to 1, you add 4. Let's see if we add 4 each time. 1 plus 4 is 5. 5 plus 4 is 9. 9 plus 4 is 13. Looks like you're adding 4 each time. That would be arithmetic. Okay, so we're going to look at special types of sequences in series now. We're going to look at ones called arithmetic. And there's a couple different definitions. They mean the same thing. One definition for an arithmetic sequence is it's a sequence where the difference between consecutive terms is constant. Okay, or you can think of it as a sequence where the terms increase by a constant. And I put decrease here. They can decrease. If they are decreasing, you look at them as increasing by a negative. Always look at it in terms of increasing. And that common difference between two consecutive terms we call D. Okay, so if you think you understand that, then go ahead and try this one on your own. Try to identify if these following 4 sequences are arithmetic or not, and if they are, find D. If you're not quite sure, then it's okay. We're just learning it, so we'll go ahead and do these together. So you can pause the video or not right now. Okay, so let's look at part A. So remember, we always want to think of it in terms of increasing. So to go from -3 to 1, we add 4. So let's just double check and make sure we add 4 each time. 1 plus 4 is 5. 5 plus 4 is 9. 9 plus 4 is 13. Huh, look at that. Looks like it works. So this first one is arithmetic. And because we're increasing, we add 4 each time. Then we say D is 4. Okay, let's look at part B. So to go from 2 to 5, you add 3. So let's just make sure we add 3 each time. 5 plus 3 would be 8. Oh no, that's a 10. Right there, that's enough. That's enough to say it's not arithmetic. We are not adding the same thing each time. Okay, let's look at part C. So you may look at 2, 4, 6, 8, 10, and we're just increasing by 2 each time. I mean, the signs alternate, but does that really matter? And the answer is yes, it does. Because you still look at just one term to the next. What do you add? 2 plus -6 would be -4. So we're adding -6 to the first one. Is -4 plus -6 equal to +6? Nope. This is not arithmetic then. Yeah, there's a pattern. And the pattern is kind of arithmetic, but it's not exact. Okay, let's look at D. To go from 10 to 7, we subtract 3. But remember, we always want to look at it increasing. So yes, we subtract, but that means we add a -3. And 7 plus -3 is 4. And 4 plus -3 is 1. And 1 plus -3 is -2. Well, look at that. This last one is arithmetic. And D is -3. So that's what an arithmetic sequence is. So let's look at writing an explicit formula for arithmetic sequences. So when you're increasing or decreasing by the common difference, that's actually linear. That's what linear functions do. So arithmetic sequences are linear. And that means we can use this y equals mx plus b to help us out. There's a couple of different ways that you'll see this formula written, like the formula to find the formula. You'll see what I mean by that. The main thing though is you need to find m and you need to find b. Well, remember that in linear equations, m is the slope and b is the y-intercept. Slope is what you increase by each time. That's also d. That'll be the common difference. And the y-intercept is the starting amount, but the main thing is, for how we're going to write it here, this is when x is 0. And that's going to come into play, you'll see. So it may look at, like, okay, so let's actually first go ahead and look at this example. We did this up above. We know that the common difference is -3. You're adding -3 each time. So that's your slope. Now remember, we're always going to write it as a sub n equals, not y equals. So you have your slope, but then what do you add? And you may go, well, b is just our starting amount. We learned that when we learned about linear equations, that b is always, like when you look at a word problem, b is your starting amount, and we're starting at 10, so it may be tempting to say plus 10, but does that work? If we let n equal 1, then we're saying a sub 1 is -3 times 1 plus 10. But wait a minute. -3 times 1 is -3 plus 10. That would be 7. That's actually our second term, not our first term. Huh. So wait a minute. What's going on here? What's going on here is this, and some of you may already see it. Remember making the table? And we let n equal 1, 2, 3, 4, and the first term is 10, the second term is 7, the third term is 4, the fourth term is 1. Remember, the y-intercept in this equation is when x equals 0, and in this case, n. We need to think of the 0th term when we're doing this. You need to back up 1. And so if you follow this pattern backwards, then we would have a 13 here. This 10 up here should actually be 13. And then when you try it, if you let n equal 1, -3 times 1 plus 13 is 10. That's going to work. In fact, even if we look at the fourth term, when n is 4, -3 times 4 is -12, plus 13 is 1. When n is 4, it's 1. So this works. So the key is you have to go backwards 1. You have to look at the 0th term. And I'm putting my fingers in quotes when I say that. We don't really have a 0th term, but you have to think of that when you're thinking of your y-intercept for this. So what does that really mean? That means this. There are, well, in this problem we have this, but if we want to generalize this, so formula to find the explicit rule for arithmetic sequences. So it's going to start off like our y equals mx plus b. Y now is a sub n. Our slope is our common difference. And instead of using x's, we're using n's. But now instead of a y-intercept, one way you'll see this formula written is like this, where they just write it as c. Whatever c is, well, c is that 0th term. And remember, to find that, rather than starting at the first term and adding the common difference, we subtract it. You have to go backwards. So c is the first term minus the common difference. Personally, I like this form better. It may seem really confusing right now, but when we do some examples next, you'll see, oh yeah, that's really easy. So I like this one because it's just quick and easy. You don't have to show any work. You can just write the formula. But another equivalent way of writing it, you'll see this. A sub 1, or a sub n equals a sub 1 plus n minus 1d. And what that is you're starting at the first term. You don't add d yet. The second term is the first term plus d. The third term is the first term plus 2d, and so on. So let me write this out here. So remember, you start at the first term, and then you add d, then you add another d, then you add another d. So the first time you're not actually adding any d's. So the first time, when n is 1, you're adding no d's. But the second term, when n is 2, you're adding 2 minus 1, you're adding 1 d. If we jump down to 4, the fourth term you're adding 3 d's. So 4 minus 1 is 3, so you're adding 3 d's. So this is another way to do it. However, you'll see if you use this form, you're going to have to simplify your answer. Either way is fine. I just personally, I'm going to be using this one because it's just so quick and easy. So let me go ahead and put this in a nice little cloud. And then let's look at some examples. Okay, so let's take a look at these. The first three are pretty straightforward. Part D. It's only given us 2 terms. Wait a minute, what? We'll take a look at D also. But if you want to pause the video, try these on your own, and we'll take a look at them one at a time. Okay, so pause the video right now to try them. Okay, we're going to work these out together, but I just want to show you just how nice and easy it is. So for the first one, it looks like we're adding 2 each time, so D is positive 2. So thinking about y equals mx plus b, each term is mx plus b, but this time our slope is 2. And remember, we can't write plus 7. We have to imagine what would come before. And in that case, it would be a 5 if you work backwards. We're adding 7 each time, so this time go backwards. And 7 minus, sorry, we're adding 2 each time. I think I said 5. You add 2. 7 plus 2, 9 plus 2, 11 plus 2. So this subtract 2, and you get 5. And that's all there is to it. Now, if you use that other form, I just want to show you how that other form works. And I'm only going to do it on this first one, and then I'm not going to do it again. Remember, that one says a sub n is a sub 1 plus n minus 1d. Well, our first term is 7, and our d is 2. But then you have to simplify that, distribute the 2, and then 7 minus 2, you can combine that and get 5. And we do get the same thing. A sub n is 2n plus 5. It's just here you have to work it out and simplify, and here it's just all done in your head. So it's much more efficient this way. So that's why I like this one better. Okay, so like I said, I'm going to, I'll save this for the notes. I'm just going to make it a little smaller. Put it off to the side here. So that's a little extra. Okay, so let's take a look then at this next one. You have to find your D first of all. And it looks like we're adding 11 each time. So D is 11. So a sub n is 11n. 11 is your slope. But then go backwards. If you subtract 11, 5 minus 11 would be negative 6. And so, minus 6. You got it. The next one. This time we're decreasing, so D is going to be negative, and it looks like we're decreasing by 4 each time. So D is negative 4. So a sub n is negative 4n. Think of negative 4 like your slope. But, again, what comes before? Well, this time if we add 4, we're going to get 17. So plus 17. Isn't that beautiful? So much nicer. All right, so then what about D? D is different. So let's take a look at what's going on with D. Remember, our formula is a sub n equals dn plus c. we need to find D and we need to find C. D is easy. D is slope. You can basically think of the slope formula. D is by2 minus y1 over x2 minus x1. You'd have to put the y values on the top. The y values are your outputs, so that's like 55 and 10. And the x values are your inputs, so that's like 21 and 6. And so then we have 45 over 15, and D is 3. So that part was easy. And always double check that your sign is right. To go from the 6th term to the 21st term, we went from 10 to 55, so we're increasing, so D should be positive, and we're good. Okay, so we have D, but now we have to find C. And we can use this formula right here to find C, because we have everything we need. You can think of these as points that you're going to plug in. You can use either one of these. I'm going to go ahead and I'll just use the first one, the smaller numbers, and hey, it's got a 10. So the term was 10. Oops. When n is 6, and we also know that D is 3. So I just plugged in. We get 10 equals 18 plus C, so C is negative 8. And then we have D is 3n minus 8. And voila, there's the answer. And you can go ahead and plug in when we have 6. 3 times 6 is 18. 18 minus 8 is 10. You can go ahead and try here. When you plug in a 21, 3 times 21 is 63. And 63 minus 8 would be 55. Oh, look at that, it works. So that's the easiest, most straightforward way, but you can also think about it just kind of conceptually. To go from the 6th term to the 21st term, that's going up by 15 terms, and we increased a total of 45. So if 15 terms we increased by 45, you can divide to find each term you went up by 3. You're still doing the exact same arithmetic. To get the 45, you had to subtract. To get the 15, you had to subtract, and then you divide. It's just looking at it conceptually. And then likewise here, if you want to know what, remember this is like the 0th term. So you're starting at 6, you have to go to the 5th, 4th, 3rd, 2nd, 1st, 0th. You have to go down 6. So you have to subtract 3 6 times, and 10 minus 18 is going to give you that negative 8. But look, that's exactly what you're doing over here. You're going down 6 times by 3, and starting at 10, if you go down that amount, you get negative 8. Like, it's all here. So you can use the formulas to guide you if you like to trust in the formulas. If you're one of those people that thinks more conceptually, you can think that way. You're still going to be doing the exact same thing. All right, so that is arithmetic sequences. All right, so just like a series was the sum of the terms of a sequence, well, an arithmetic series is the sum of the terms of an arithmetic sequence. So just some really basic ones. 3 plus 6 plus 9 plus 12 plus 15. We looked at that the last video. That is an arithmetic sequence of 3, 6, 9, 12, 15, but then you're adding them, so it turns into a series. You could also have 10 plus 7 plus 4 plus 1 plus... Each term represents a term of an arithmetic sequence, but we're adding them up, so it's an arithmetic series. So that's all an arithmetic series is. But now let's look at actually evaluating arithmetic series. How do you do that? So there's a classic example. Find, excuse me, the sum of the integers from 1 to 100. All right, go. Whoever can do it the fastest without a calculator. Heck, you can even use a calculator if you want to. Go ahead. And so try to do it. It's 1 plus 2 plus 3 plus 4 plus plus. Eventually you get to 97, 98, 99, and 100. Whew. Okay. And we'd have to add all those numbers, including the ones and the dot, dot, dot. And you may think, well, that's just a really tedious problem to do. Sure, we could all do it. It's actually a nice, efficient way of doing it. So if you add the first and the last terms together, you get 101. Now if you add the second plus the second to the last, 2 plus 99 is 101. 3 plus 98 is 101. 4 plus 97 is 101. We would have a whole bunch of 101s. In fact, how many 101s would we have? Well, we're pairing the numbers. There's 100 numbers altogether, so that means that there's 50 pairs. So 101 times 50 is 5,050. Boom, we're done. Aha! And that's the idea, actually, that you do with this. So, okay, so what's going on here then? So the nth partial sum, I'm going to put this nicer down below, but the nth partial sum, if you look at this problem, what did we do? We took the first term and the last term and added them together. And then we multiplied by the number of pairs that we would get. So the number of pairs, if you take the number of terms and divide by 2, that gives you the number of pairs. And that's basically our formula right there. I'm also going to derive this another more formal way. So let's take a look at another way to do this that's more formal. So the sum of the first n terms of an arithmetic series. We know the first term would be a sub 1. The next term would be a sub 1 plus d. The next term, we would have to add another d. The next term, we would have to add another d. And so on and so on. We add all these together until eventually we do get to that last term. The sum of the first n terms, we're going to add all the way up to the nth term. Now I can take this and write it pretty much the same way, except just put all the terms in backwards order. I can put the last term first. But then what comes right before that is a sub n minus d. And what comes right before that? I have to subtract off another d. And what comes right before that? I have to subtract off another d. And we would keep doing that until we get back down to the first term. Okay, so why would I do that? Well, look at what I can do with this. I can take these two finite sequences or series and add them together. If I add on the left, s sub n plus s sub n is 2 s sub n. But let's look at it term by term here. Let's look at it vertically. So if I'm looking at these guys, they add up to a sub 1 plus n, plus a sub n. So that adds up to this. And then what about these? What do they add up to? Well, the d's are going to cancel out, and we're going to have a sub 1 plus a sub n. Okay, so let's look at these guys. What do they add up to? Well, the 2d and minus 2d cancels out. So we're going to have a sub 1 plus a sub n again. And then that's going to keep happening. The 3d and minus 3d cancels out. We're going to have a sub 1 plus a sub n. And we're going to keep going until the last one's is still a sub 1 plus a sub n. So we can condense this now. How many of those are we going to have? Well, we had the first term, second term, third term, fourth term, all the way up to nth term. We're going to have n of these pairs. So it's going to be n of these. And then if we solve for s sub n, we get n over 2 times a sub 1 plus a sub n. Which if I scroll, you can see that that's equivalent to what we had up here. So it's just two different ways of looking at the same formula. But that's the formula to find the sum of the first n terms of an arithmetic series. So the nth partial sum of an arithmetic series is S sub n is n over 2 times a sub 1 plus a sub n. And I am going to put here n is the number of terms, a sub 1 is the first term, and a sub n is the last term. Okay, let's go ahead and look at some examples, and that will finish things up for us. Okay, so here's the first one. And again, if you want to pause the video and try these on your own, go ahead and we'll take a look at it together right now. Okay, so with each one of these problems, they're going to give you something slightly different. And so each one's done slightly differently, but I like to let the formula be your guide. So we know the formula says S sub n equals n over 2 times a sub 1 plus a sub n. Let's make sure we know all the parts. We know that we're trying to find the 30th partial sum, so n is 30. And this n is 30. A sub 1 is the first term. We know that that's 4. A sub n. We don't know the last term. Well, we have to find a formula for this. So we know n is 30. We know a sub 1 is 4. But we need to find a sub n. But we can see that we're going up by 3 each time. So it's going to be 3n. And then remember, go backwards 1. So instead of adding 3 each time, just subtract 3. And you're going to have plus 1. Huh, we have a sub n now. Ta-da! And we can even find a sub 30. You can find it out here or plug it into the formula. It doesn't matter. That's going to be 90 plus 1, so it's 91. We have everything we need now. We go ahead and plug it in. So the 30th partial sum is 30 over 2. And then first term was 4. And the 30th term is 91. So it's going to be 15 times 95. And I am going to use my calculator for this. I know that the 30th partial sum is going to be 1,425. So again, I started off with a formula, but then I looked at what I had and what I needed to find, and then I had this problem that I had to work out on the side. I didn't know a sub n. Sometimes you have everything you need and you can plug it right into the formula. Sometimes you don't. And so sometimes you have a little bit of extra work before you can actually plug everything in the formula. So there's first example. Okay, so now let's look at this one. Oh, this time it's given in summation notation. Okay, let's see if this one's any different then. So again, if you want to pause the video, go ahead. Otherwise, let's look at it together. So the first thing, we're talking about arithmetic sequences and series, so we're probably dealing with an arithmetic series right here, but you can always spot one. If the argument is linear, then you know it's arithmetic. So when we start jumbling things up with other concepts, with other types of series, that's how you can always spot you've got an arithmetic one. Okay, arithmetic, that means we're going to deal with this formula. So let's make sure we know everything. Well, do we know how many terms we're going to be adding? To go from 1 to 15, that's going to be a total of 15 terms. So n is 15. The first term. How are we going to find the first term? Well, we're starting at 1, so just plug in a 1. So it's going to be negative 10 minus 3 times 1. So it's going to be negative 13. And then what's a sub n? Well, a sub n is the last term. We're ending with 15, so we're going to plug in a 15 here, and we have that. So that's negative 10 minus 45, so it's going to be negative 55. So it does. It looks like we have everything we need. We can go ahead and plug it into the formula and go with it. So the 15th term is 15 over 2 times negative 13 minus 55. I'm going to go ahead and leave this here because 15 over 2, that would be a decimal. I mean, I'm using a calculator. It won't be that bad. But if I was doing this by hand, I would do this first in the parentheses because that's going to give me an even number. And then I can divide that one by 2 and just deal with 15 times 24. A little easier that way. And so I'm going to get negative 360. So there's our second one. I got 2 more examples I'm going to do with you. Okay, so let's take a look at this one. Again, pause the video if you want to try it on your own. Otherwise, we'll take a look at it together. Okay, so again, we got to make sure that we know everything. Now this one has a trick. I am not starting at 1, I'm starting at 10. So how many terms are there from 10 to 40? Remember, I got to include 10 and I have to include 40. So I don't just subtract. If I subtract, I'm not including the 10. So 40 minus 10 would be 30, but then I have to include the 10. There's 31 terms. To convince yourself if you don't get what I'm talking about, imagine I assigned problems 10 through 40. Think about how many homework problems that would be that you would have to do for homework. So we know what n is. Now we have to be also careful here. Remember, a sub 1 is the first term. I'm not actually plugging in 1 for the first term. I'm starting at 10, so I'm going to plug in 10 for the first term. So it's 2 times 10 plus 7, which is 27. And then a sub n is the last term. So the last term means I'm going to plug in 40. So it's 2 times 40 plus 7, so it's 87. So think about that if you have to, but you got to be careful. That's why I specified up above what each part in the formula was. N is the number of terms. A sub 1 is the first term. A sub n is the last term. But now we have everything. We can plug into our formula. So here's the formula. So the 31st partial sum is 31 over 2 times 27 plus 87. And I'm just going to go ahead and work that out right now. And we are going to get 1,767. And there it is. Okay, like I said, one more example now, and that'll be the end. Okay, so our last one's a little different, but consider the series 4 plus 7 plus 10 plus 13, so on. How many terms do you need to add to get a sum of 175? So again, let the formula be your guide. Pause the video and try to think about this on your own, but we'll look at it together. Okay, so we're going to write down the formula. So this time, we're trying to find n. So we're not going to plug in anything for n. We know the first term is 4. If we don't know how many terms we're adding, how can we find the last term? Well, that's okay. We may not be able to find the actual value, but we can find a formula. Each time we're adding 3, so we know our slope is 3. And if we go backwards 1, 4 minus 3 is 1. We're going to use that for our formula. And it's okay that we don't have anything to plug in for n, because that's what we're trying to find. We have everything. In this case, we know that our sum, we don't know what n is, but we do know that the actual sum is going to be 175. So we just plug in now, and we're going to solve for n. So this is 175. We don't know what n is. We know the first term is 4. And we don't know what n is, but we do know a formula for the nth term will be 3n plus 1. And now we have a formula that we're going to work out. So if I just multiply both sides by 2, I'm going to get 350. And then if I combine what I get in there, I have 3n plus 5. And oh goody, this is going to be a quadratic. Yes. Now this one's kind of an ugly quadratic. You can try factoring it. But by the way, a little note, n should be a whole number. These should always factor. So you can try factoring if you want. Honestly, when the numbers get like this, I'll probably go to the quadratic formula, especially since I already have a calculator. So I snap my fingers and voila, here's a quadratic formula worked out. So we're getting 10 and we're getting negative 70 over 6. And remember, n is how many terms you're supposed to be adding. So first of all, you can't have a fraction, and you also can't add a negative number of terms. So n has to be 10. We're getting 10 or negative 70 over 6. I could simplify that, but I'm just going to throw that number away anyway. We're going to add 10 terms. All right, that's it. Have fun with your homework this week. Bye.